When we look at galaxies in space images, they often seem close together. The Milky Way here, Andromeda there. A few bright spirals scattered across the darkness. It almost feels as if galaxies are islands floating near each other in a cosmic ocean. But this picture is deeply misleading. The true distance between galaxies is almost impossible for the human mind to understand. Andromeda, the closest major galaxy to the Milky Way, is more than 2 million light-years away. That means the light reaching us from Andromeda began its journey before modern humans even existed. And yet, on the scale of the universe, Andromeda is considered our neighbor. Beyond it, the distances become far worse. Galaxies are separated by millions, tens of millions, and even billions of light-years. Between them lies a darkness so vast that entire civilizations could rise and vanish without ever crossing it. Tonight, on What If Beyond, we will explore the terrifying scale between galaxies. We will discover why intergalactic space is so empty, why even the closest galaxies are almost unreachable, how fast light truly is across these distances, and why the universe may be far larger and more isolated than it appears. Because the distance between galaxies is not just big, it is worse than anything we can imagine. Before we continue, tell me in the comments, what time is it where you are right now? And from which city are you listening? And if you enjoy calm documentaries about deep space, galaxies, and the mysteries of the universe, consider subscribing to What If Beyond. Now, dim the lights, get comfortable, and let us begin a journey across the impossible distance between galaxies. From Earth, galaxies look almost close. A spiral of light here, a faint smudge there, a bright oval in a telescope image, a cluster of glowing islands scattered across the darkness. When we see them on a screen, they seem as if they belong to the same picture, separated only by small gaps of black space. The Milky Way, Andromeda, Triangulum, the distant galaxies of the Hubble Deep Field, all of them appear together in our imagination like objects placed on a cosmic table. But that image is deeply false. The distance between galaxies is not simply large. It is the kind of distance that breaks the ordinary meaning of travel. It is a distance so vast that light itself, the fastest thing in the universe, becomes slow. A distance where time becomes part of the measurement. A distance where a journey is not counted in years, or centuries, or even the lifetime of a civilization, but in spans so enormous that entire species could appear, evolve, vanish, and leave no trace before the crossing was complete. To understand this, we must begin with our own galaxy. The Milky Way. It contains hundreds of billions of stars. It stretches across roughly 100,000 light-years. If you could travel at the speed of light, it would still take about 100,000 years to cross from one side of the galaxy to the other. That alone is already beyond human experience. The entire history of written civilization is only a tiny fraction of that time. The first cities, the first empires, the oldest monuments, the rise and fall of languages, all of them fit inside a few thousand years. A light beam crossing the Milky Way would need far longer than that. But here is the strange part. The Milky Way is only one galaxy. And even the nearest major galaxy is not just outside the door. Andromeda is roughly 2.5 million light-years away. 2.5 million years for light to cross the darkness between us. That means when we look at Andromeda tonight, we are not seeing it as it is right now. We are seeing it as it was more than 2 million years ago. The photons entering our eyes began traveling before modern humans existed, before cities, before agriculture, before language in the form we know it, before every civilization ever built on Earth. The light crossed intergalactic space while Earth changed beneath it. Ice ages came and went. Animals evolved. Human ancestors walked across ancient landscapes. Generations were born and died. And only now does that light arrive. Andromeda is called our neighbor. That is the most disturbing part. In cosmic terms, it is nearby. It belongs to the same small family of galaxies as the Milky Way, a group known as the local group. It is one of the closest large galaxies to us. And yet, if we wanted to send a message there at the speed of light, the message would need more than 2 million years to arrive. If someone in Andromeda replied immediately, the answer would return after another 2.5 million years. One conversation would take 5 million years. A simple hello would become an exchange longer than the existence of our species in its modern form. This is the first lesson of intergalactic distance. Galaxies can be neighbors and still be unreachable. Nearby does not mean close. It means less impossible than everything beyond it. If the Milky Way were reduced to the size of a city, Andromeda would not be across the street. It would still be separated by a distance so large that the comparison begins to lose meaning. The universe operates on scales where human words become weak. Far, distant, huge, these words were created for mountains, oceans, countries, planets, perhaps stars. But galaxies require another kind of imagination. The space between them is not an empty hallway waiting to be crossed. It is an abyss of time, a region so wide that even if a spacecraft could travel faster than anything humanity has ever built, the journey would still be almost beyond comprehension. The fastest spacecraft we have sent into deep space move at speeds of tens of thousands of kilometers per hour. That sounds extremely fast. On Earth, such a speed is almost unimaginable. A plane would cross continents in minutes. A vehicle would circle the planet quickly. But compared with light, these speeds are tiny. Light travels about 300,000 kilometers every second, not every hour. Every second. In 1 second, light can travel around Earth more than 7 times. In 1 year, it crosses nearly 10 trillion kilometers. That distance is called 1 light year. Now imagine 2.5 million of those. That is the distance to Andromeda. And Andromeda is only the beginning. Beyond the local group, galaxies are separated by distances of tens of millions of light years, then hundreds of millions, then billions. The farther we look, the more the universe becomes a field of isolated lights separated by unimaginable darkness. When we look at deep field images, thousands of galaxies appear in a small patch of sky. The image feels crowded, it feels full, but that fullness is another illusion created by distance. The galaxies are not packed together in a small region. They are spread across vast depths of space and time. Some are millions of light years away, others billions. Some are seen when the universe was much younger, others are closer and more mature. The image compresses 3-dimensional depth into a flat picture. It makes the universe appear crowded because it hides the distances between the layers. A galaxy behind another galaxy may be billions of light years farther away. 2 bright points that appear side by side may have nothing to do with each other. They may be separated by a span so huge that one is seen in the ancient past and the other in a more recent cosmic era. The sky is not a surface, it is a depth. Every direction leads through layers of time. The same is true when we look beyond the Milky Way. From Earth, Andromeda is visible as a faint patch under dark skies. To the naked eye, It appears small and soft, almost like a cloud. But that patch contains roughly 1 trillion stars, perhaps more. It is larger than the Milky Way in visible extent. Its disk stretches across space with spiral arms, dust lanes, star clusters, and a bright central region. If Andromeda were much brighter in our sky, it would appear several times wider than the full moon. It only looks faint because of distance. The galaxy is enormous, the light is ancient, and the darkness between us is almost completely empty. This emptiness is important. The space between galaxies is not filled with stars the way a galaxy is. Inside the Milky Way, stars are already separated by vast distances. The nearest star system to the Sun is more than 4 light-years away. That is already a distance our current spacecraft would need tens of thousands of years to cross. But between galaxies, even stars become rare. Intergalactic space contains gas, dark matter, radiation, magnetic fields, and wandering objects. But compared with galaxies, it is incredibly empty. A spacecraft leaving the Milky Way toward Andromeda would not pass through a dramatic field of suns. It would not see planets drifting everywhere. It would spend most of its journey inside darkness. The Milky Way would slowly shrink behind it. Andromeda would slowly grow ahead. For most of the trip, both galaxies would appear as distant objects. The traveler would be between homes, not inside one galaxy, not yet inside another, suspended in the vastness between them. This is one of the loneliest environments imaginable. If a human crew were somehow aboard such a spacecraft, the psychological meaning of the journey would be difficult to understand. After leaving the Milky Way, they would no longer belong to the sky that created them. The constellations would begin changing. The Sun would become a star lost inside the galactic glow. Earth would disappear completely. No telescope on the ship could see oceans, continents, or cities. Home would become a coordinate, a memory, a story preserved in data. Ahead, Andromeda would remain too far away for any immediate hope. The crew would live between galaxies, inside a darkness larger than the entire Milky Way. And if the ship traveled at ordinary spacecraft speeds, the journey would not last generations. It would last far longer than any civilization has ever survived. This is why intergalactic travel is not simply a harder version of interstellar travel. It belongs to another category. Traveling to the nearest stars is already almost impossible with current technology. Traveling to another galaxy is something else entirely. Even if a future spacecraft could reach 10% of the speed of light, an extraordinary speed far beyond anything we can currently achieve, Andromeda would still be about 25 million years away. 25 million years. At that speed, time dilation would not be enough to make the trip short for passengers. The ship would need to survive across geological time. It would need to endure long enough for continents on Earth to shift dramatically, for climates to transform, for species to evolve, for languages and cultures to vanish, for the galaxy itself to change. The people who launched the mission would not be remembered by anyone waiting at the destination. The destination itself would not be the same as the Andromeda seen from Earth. We see Andromeda's past. The ship would arrive in Andromeda's future. Millions of years would pass during the crossing. Stars would move. Some would die. Others would form. Supernovae would explode. Planetary systems would evolve. Aiming for a galaxy is not like aiming at a fixed island. The island moves. The ocean expands. The traveler ages. The universe changes during the journey. This creates a strange problem. When we look at distant galaxies, we are not seeing destinations as they are now. We are seeing old light. A galaxy 10 million light-years away is seen as it was 10 million years ago. A galaxy 1 billion light-years away is seen as it was 1 billion years ago. If we decided to travel there, we would not be traveling to the galaxy in the photograph. That version is gone. We would be traveling toward the place where the galaxy has evolved since that light left it. The universe we observe is not the universe we would arrive in. Astronomy gives us access to history. Travel gives us access only to the future. This difference becomes more dramatic with distance. A galaxy seen 5 billion light-years away appears as it was before the Sun was fully mature in its present form. If we could somehow begin traveling toward it today, the galaxy we reached would have had billions of years to change. But because the universe is expanding, the journey may be impossible, no matter how fast we try to go. This is another frightening truth. Some galaxies that we can see today can never be reached. Their light was emitted when they were much closer to our region of space. Since then, the universe has expanded. The distance between us and them has grown. For very distant galaxies, the expansion of space can carry their regions away so quickly that a signal sent from us today would never arrive. Not because the signal travels slowly in local space. Light still moves at light speed, but the space between large-scale regions continues growing. The path stretches as the light tries to cross it. This means the observable universe is not the same as the reachable universe. We can see farther than we can ever travel. The sky contains places that are already beyond any possible future contact. They are visible because their ancient light reached us, but their current reality is permanently separated. This makes intergalactic distance more than a matter of engineering. It becomes a boundary created by space-time itself. No rocket can solve every distance. No fuel tank can overcome every horizon. Some parts of the universe may be forever outside our causal future. This idea is difficult to accept because we are used to thinking of visibility as access. If we can see a mountain, we can imagine walking toward it. If we can see a planet, we can imagine sending a probe. If we can see a star, we can imagine a distant mission. But cosmology breaks this intuition. A galaxy can be visible and unreachable. Its light can arrive while our own light can never reach it. The universe permits one-way information from the past without allowing future contact. This is one reason the distance between galaxies is worse than it appears. The darkness is not only large, it is growing. The space between unbound galaxies expands. The farther a galaxy is, the faster it generally appears to recede, because there is more expanding space between us and it. This expansion is not the same as a galaxy moving through space like a spacecraft. It is the stretching of space itself. Galaxies held together by gravity do not expand internally in the same way. The Milky Way is not stretching apart because of cosmic expansion. Neither is the solar system. Gravity and other local forces hold them together. But between galaxy groups that are not gravitationally bound, expansion dominates. The distances increase. The universe becomes more isolated over time. The Milky Way and Andromeda are exceptions because they are close enough and gravitationally connected. They are moving toward each other. In several billion years, they are expected to interact and eventually merge. This may sound comforting, as if intergalactic distance can sometimes close. But it is only true locally. Our local group will remain bound. The galaxies inside it will merge and reshape one another. Meanwhile, most distant galaxy groups will move farther away. In the far future, after the Milky Way and Andromeda have become one larger galaxy, the rest of the universe may fade beyond reach. Distant galaxies will become dimmer, redder, and eventually invisible. Future astronomers in that merged galaxy may look outward and see a much emptier cosmos. They may not have easy evidence of the vast cosmic web we see today. They may believe their island galaxy is nearly alone. The universe is not only separated by distance, it is becoming more separated with time. This gives our era a special kind of value. We live at a time when the universe is old enough for galaxies, planets, and life to exist, but young enough that distant galaxies are still visible. The cosmic web can still be mapped. The ancient light of the early universe can still be detected. The expansion can still be measured. We can still see far enough to understand that the Milky Way is not alone. In the distant future, much of this evidence may disappear from local view. The universe will hide its own size. But even today, when galaxies remain visible, the scale between them is almost impossible. Consider again the Milky Way and Andromeda. They are approaching each other, but the encounter will not happen for billions of years. Even though the two galaxies are gravitationally linked, the distance is so large that the fall takes a cosmic age. Andromeda is moving toward us at a speed far beyond anything humans experience in ordinary life. Yet it still needs billions of years to arrive. This tells us something powerful. At galactic scales, even enormous velocities can look slow. Speed loses its emotional meaning when the distances are too large. A galaxy can race through space and still appear almost fixed during all of human history. Our lives are too short to see the motion directly. The sky appears calm because the changes unfold over millions and billions of years. If we could watch the universe in extreme fast forward, the stillness would vanish. The Milky Way and Andromeda would drift together. Dwarf galaxies would orbit and dissolve. Clusters would evolve. Galaxies would merge, stretch, and transform. The cosmic web would grow. Distant structures would recede. But in human time, the universe appears almost frozen. This is the same illusion we experience with mountains and continents. A mountain seems permanent, but given enough time, it rises, erodes, fractures, and disappears. A continent seems stable, but given enough time, it splits, drifts, collides, and forms new continents. Galaxies also change. They simply do so on scales that dwarf human memory. The distance between galaxies contributes to that illusion. Because galaxies are so far apart, their movements become slow stories. The Milky Way and Andromeda are approaching, but no human can notice the change across a lifetime without precise measurement. The light from Andromeda remains soft and steady. The night sky appears unchanged, yet the future encounter is already underway. Gravity has already linked the galaxies. Their dark matter halos may already interact. The distance is closing. The merger is part of our cosmic future. But even this collision will not be like objects crashing together in a small room. Galaxies are mostly empty space. When they merge, stars rarely hit one another directly. The distances between stars are too large. Instead, gravity rearranges the entire structure. Spiral arms stretch. Gas clouds collide. New stars may form. Some stars may be thrown into wide orbits. The galaxies pass through and around each other before settling into a new shape. A galactic collision is violent in structure, but not usually in direct impacts between individual stars. Again, scale changes the meaning of events. Two galaxies can collide, while most stars never touch. The distance between stars inside galaxies is already huge. The distance between galaxies is even worse. This is why the universe is both full and empty. It contains hundreds of billions of galaxies. Each galaxy may contain hundreds of billions of stars. The numbers are overwhelming. And yet, most of the volume of the universe is darkness. Objects are tiny compared with the spaces between them. Matter gathers into islands. The islands gather into groups and clusters. The clusters form filaments. The filaments surround voids. But the voids occupy enormous volumes. The universe is structured like a web, not like a solid substance. Galaxies trace the threads. Between the threads lie regions containing far fewer galaxies. Some cosmic voids span hundreds of millions of light years. Imagine crossing a region so empty that entire galaxies become rare landmarks. A spacecraft traveling through such a void might see distant galaxies in every direction, but locally there would be almost nothing. No nearby stars, no planets, no familiar points of reference, only darkness and ancient light. If a planet somehow existed inside a deep void, its night sky might look very different from ours. It might have a home star, perhaps a few nearby stars, but distant galaxies could be faint and sparse. Its astronomers might struggle longer to discover the large-scale structure of the universe. They might believe the cosmos is emptier than we do. Where a civilization lives can shape how it understands reality. Humanity lives inside a galaxy that belongs to a group near larger cosmic structures. We can observe enough of the universe to recognize patterns, but the universe does not look the same from every location. Some observers may live in crowded clusters. Their skies may contain many bright galaxies. Others may live in isolated regions where the cosmic web is harder to detect. The same universe can feel different depending on where consciousness appears. This adds another layer to the distance problem. Not only are galaxies separated by vast space, but information about the universe depends on position. A civilization in one galaxy may never know what exists beyond its horizon. Another may see a richer sky. Another may be cut off by dust or by cosmic expansion. Knowledge is local. Even in a universe governed by universal laws, every observer begins inside one limited window. Our window shows us that galaxies are separated by impossible distances. It shows us that Andromeda is a neighbor and still millions of light years away. It shows us that deep fields contain thousands of galaxies, but hide the immense depth between them. It shows us that space expands and that some visible regions cannot be reached. And it shows us that the universe is not designed for easy travel. This may be the most humbling part. Science fiction often imagines galaxies as places to cross. A ship jumps from one spiral arm to another. Civilizations trade between star systems. Empires span galaxies. And for storytelling, those ideas are powerful. But the real universe is far less convenient. Even crossing one galaxy is a task beyond any technology we currently possess. Crossing the space between galaxies is a challenge so enormous that it may remain forever impractical for biological beings. The distances do not care about ambition. They do not become smaller because we want to explore. They do not bend to the human sense of adventure. They simply exist. Cold, silent, expanding, and yet we can know them. This is the remarkable contrast. We may never travel to Andromeda. We may never cross a cosmic void. We may never send a probe beyond the local group. But photons have already made the journey. Light from Andromeda reaches us. Light from galaxies billions of years away reaches us. The universe sends information across distances that matter cannot easily cross. Every telescope becomes a receiver of ancient messages. Every deep space image is proof that the darkness is not completely silent. It carries light. It carries history. It carries the evidence of galaxies that existed long before Earth formed. When we look up, we do not physically leave the Milky Way, but our vision does. Our instruments gather light from beyond our galaxy. Our minds reconstruct distances no body could survive crossing. In that sense, astronomy is the only form of intergalactic travel humanity currently possesses. Not travel of flesh, not travel of machines, travel of understanding. We cross the distance by reading the light that crossed it first, but understanding the distance also forces us to confront isolation. The Milky Way may contain countless planets. Andromeda may contain even more. The universe may contain worlds beyond number, but the distance between galaxies means that most of these worlds are separated by barriers of time. If life exists in Andromeda, we see its galaxy before any modern human civilization existed. If a civilization there looked at the Milky Way, it would see our galaxy as it was more than 2 million years ago. Earth would not reveal our cities. Our radio signals have not traveled even close to that far. Humanity is completely invisible across that distance. To Andromeda, if anyone is watching now, Earth is a prehistoric world. And to us, Andromeda is ancient. Intergalactic communication would not be conversation. It would be archaeology. A message sent today might arrive after millions of years. The sender could be gone. The receiver could be different. The meaning could be lost. A reply would return to another age. This makes even contact between galaxies feel almost impossible. Not because signals cannot travel. They can. But because the time involved destroys ordinary communication. A message becomes a fossil of intelligence. A civilization announces itself, but no dialogue follows. The universe may be filled with such messages, too faint or too old or too delayed for us to recognize, or it may be mostly silent. We do not know. The distance between galaxies ensures that even if life is common, awareness of one another may remain rare, separated not only by space, but by timing. A civilization could rise in one galaxy after another has already vanished. Signals could pass through empty regions long after their creators are gone. Two intelligent species could exist in the same universe and still never share the same accessible era. This is the loneliness of cosmic scale. The universe may be abundant and isolated at the same time, full of galaxies, full of stars, perhaps full of life, and still most things may remain unreachable to one another. The distances are not empty gaps waiting to be closed. They are part of the universe's architecture. They shape what can happen. They decide what can communicate. They determine what remains forever beyond the local story. And yet, from Earth, the galaxies still shine. They appear small, peaceful, and beautiful. A spiral galaxy in a telescope image can look delicate. Its arms curve softly. Its center glows. Its stars blend into mist. Nothing about the image communicates the true distance. Nothing tells the eye that the light traveled millions or billions of years. Nothing reveals that the darkness between galaxies is larger than imagination. Beauty hides scale. The image becomes understandable only when we add time. That faint galaxy is not just far away. It is old light. It is a messenger from another era. It is a region of space whose present state may be unknowable. It may be moving away faster than we can ever overcome. It may be part of a cosmic structure already beyond our future. The distance between galaxies is worse than it looks because images make them feel accessible. The universe places them in the same sky, but physics separates them with time. As our journey continues, we must move beyond Andromeda and the local group. We must examine the true spaces between galaxy clusters, the cosmic voids where darkness dominates, the expanding structure of the universe, and the terrifying possibility that most galaxies we see are not destinations, but disappearing memories. Because the farther we travel in thought, the clearer it becomes. The universe is not a field of nearby islands. It is an ocean whose shores are drifting apart. If the Milky Way and Andromeda are neighboring islands, then the next step in our journey reveals something even more unsettling. Most galaxies are not arranged like cities with short roads between them. They are scattered through a cosmic landscape so enormous that even groups of galaxies become tiny structures inside something far larger. The Milky Way, Andromeda, Triangulum, and many smaller dwarf galaxies form the local group. From inside it, this group already feels immense. A distance of 2.5 million light-years to Andromeda is enough to make ordinary travel meaningless. But when we zoom out, the local group becomes only one small knot of galaxies, a small family drifting near the edge of greater structures. Beyond it lies a wider universe where galaxies gather into clusters, clusters gather into superclusters, and long threads of matter stretch across hundreds of millions of light-years. The scale becomes so large that the word distance begins to change. At first, distance means the space between planets, then the space between stars, then the space between galaxies. But at the largest scale, distance becomes the shape of the universe itself. It is no longer simply a gap between two objects. It becomes part of a cosmic pattern. The nearest large galaxy cluster to us is the Virgo cluster. It lies tens of millions of light-years away. Compared with Andromeda, Virgo is far more distant. Light from its galaxies began traveling when Earth was a very different world. When those photons left, many species alive today did not exist. Continents were arranged differently. The climate was different. Life was moving through ancient stages of evolution. And only now does that light arrive in our telescopes. The Virgo cluster contains hundreds, perhaps thousands of galaxies. Spiral galaxies, elliptical galaxies, dwarf galaxies, galaxies that are still forming stars, galaxies that have grown old and quiet. Some are bright and massive, others are faint, diffuse, and difficult to detect. Together they form a gravitationally bound environment, much larger and denser than our local group. But even inside a galaxy cluster, the word dense must be understood carefully. The galaxies are closer together than they are in isolated regions. They interact. They pass near one another. Their gravity reshapes their structures. Gas can be stripped away as they move through the hot material filling the cluster. Some galaxies lose the fuel needed to create new stars. Others merge and become larger. But despite all this activity, the space inside the cluster remains mostly empty. The galaxies are like glowing cities separated by oceans wider than imagination. A traveler moving through the Virgo cluster would still spend most of the journey in darkness. The cluster might appear rich from far away because many galaxies are visible together. But visibility is not closeness. A telescope compresses distance. It places many galaxies into one image, while hiding the millions of light-years between them. If you were inside the cluster, the galaxies would be more numerous in the sky, but they would not be close in the human sense. You could see more of them. You still could not reach them easily. The Virgo cluster is part of something even larger. Our local group in Virgo belong to a broader cosmic region. often described in relation to the Virgo supercluster and larger structures around it. On still larger maps, our galactic neighborhood is associated with an immense gravitational basin called Laniakea. The name means immense heaven. It is a beautiful name for something almost impossible to imagine. Laniakea contains many galaxy groups and clusters spread across a region hundreds of millions of light-years wide. The Milky Way is only one small member inside this enormous flow of galaxies. But even Laniakea is not a solid object. It is not a wall. It is not a giant galaxy. It is a region of the cosmic web where galaxies and clusters share related gravitational motions. Matter flows through space toward denser areas. Galaxies move along invisible paths shaped by dark matter and gravity. The entire structure is not something you could see with your eyes as one bright object. It must be mapped through motion, distance, and the distribution of galaxies. This is where the universe becomes less like a collection of objects and more like a vast network. On the largest scales, galaxies are not scattered randomly. They trace long filaments. These filaments connect clusters. Between them lie voids, enormous regions with far fewer galaxies. Together, these filaments and voids create what astronomers call the cosmic web. It is one of the largest known patterns in nature. A web made not from strings, but from gravity, not from threads, but from galaxies, dark matter, gas, and time. To imagine it, think of foam, bubbles pressing against one another. The walls of the bubbles contain matter. The interiors are more empty. In the universe, galaxies gather along these walls and intersections. Clusters form where filaments meet. Voids occupy the wide regions between them. Our galaxy is not floating in a random ocean of stars. It is located within this enormous pattern, a structure built over billions of years from tiny differences in the early universe. In the beginning, matter was not perfectly smooth. Some regions were slightly denser than others, not by much, only tiny differences. But gravity amplified them. Denser regions attracted more matter. Less dense regions lost matter to their surroundings. Over time, the denser regions grew into galaxies, groups, clusters, and filaments. The less dense regions became voids. The cosmic web is therefore a fossil of the early universe enlarged by gravity. Every galaxy cluster is part of a story that began before stars existed. Every void is a region where matter gradually drained away toward denser surroundings. Every filament is a path created by gravity pulling material across time. This changes how we should think about the spaces between galaxies. They are not empty mistakes. They are part of the architecture. The universe built itself with both matter and absence. The voids are as important to the shape as the filaments. A city is defined partly by its streets. A web is defined partly by its openings. The cosmos is defined partly by where galaxies are not. Some voids are so large that they make the distance to Andromeda seem small. They can span tens or hundreds of millions of light years. Inside them, galaxies are rare. A few small galaxies make thin gas may be present. Dark matter still contributes gravity. But compared with clusters and filaments, these regions are astonishingly empty. Imagine a spacecraft entering one. Behind it, a filament of galaxies slowly fades. Ahead, only distant points remain. For millions of light years in every direction, there may be no major galaxy nearby. No bright spiral dominating the sky. No cluster filling the horizon. Only darkness, faint radiation, and the distant glow of structures far away. A traveler there would experience a kind of isolation that has no earthly equivalent. A desert still has sand. An ocean still has water. A polar ice sheet still has wind, ice, and sky. A cosmic void has almost nothing. It is not nothing in the absolute sense, but it is empty enough that the human mind struggles to treat it as a place. The spacecraft would be surrounded by volume without landmarks, distance without destination, time without scenery. This is one reason intergalactic travel feels so impossible. On Earth, even a long journey passes through changing landscapes, mountains, rivers, cities, clouds, forests, deserts. In intergalactic space, change may unfold so slowly that thousands of years could pass without a visible transformation. A nearby star does not rise over the horizon. A planet does not appear. The blackness remains. The destination grows too slowly to satisfy human senses. Travel between galaxies would be psychologically brutal because the universe would offer almost no feedback. You would be moving, perhaps extremely fast, but everything would still look almost the same. Behind you, the Milky Way would shrink over thousands or millions of years. Ahead, another galaxy would grow at a rate too slow for any individual lifetime to perceive. The journey would feel like standing still inside eternity. This is why the distance between galaxies is not only a physical problem, it is a problem of meaning. What does a journey mean when no passenger can see its progress? What does exploration mean when the destination belongs to descendants so remote they may no longer remember the origin? What does arrival mean after millions of years of darkness? If a civilization launched a generation ship toward Andromeda, the first passengers would know they would never arrive. Their children would not arrive. Their descendants, thousands of generations later, might still be far from the destination. The mission would become culture, then history, then myth. The ship itself might become the only world its inhabitants know. Earth would become a story. The Milky Way would become a bright object behind them. Andromeda would become the promise of an ancient purpose. Could such a civilization remain committed to a destination for millions of years? Would they still care? Would they change course? Would they stop somewhere else if they found a rogue planet, a dwarf galaxy, or a drifting star system? Could the idea of a mission survive longer than languages, religions, nations, and species have ever survived on Earth? The distance between galaxies forces questions that are not only scientific, they are civilizational. They ask whether purpose can cross geological time. A robotic probe would not suffer in the same way, but it would face its own impossible demands. It would need to survive radiation, dust impacts, power loss, material fatigue, software errors, and the slow decay of every system. A probe designed to last 100 years is impressive. A probe designed to last 10,000 years would be extraordinary. A probe designed to last millions of years would be almost beyond current engineering imagination. Metals weaken, circuits degrade, memory corrupts, cosmic rays flip bits, microscopic dust impacts accumulate damage, power sources decline. Even if the spacecraft never encounters a major obstacle, time becomes the enemy. The darkness between galaxies is safe in one sense because there are few large objects, but it is deadly in another because there is no help, no repair station, no nearby source of materials, and no second chance. A machine crossing intergalactic space would need to be more than durable. It would need to be self-repairing, perhaps self-replicating. It might need to mine rare drifting objects for material. It might need to use artificial intelligence to diagnose and rebuild itself. It might need to preserve not only data, but the ability to understand its own purpose after millions of years. This kind of exploration is closer to creating a living technological organism than launching a normal spacecraft. And even if such a machine reached another galaxy, communication would remain a nightmare. A probe arriving in Andromeda would send a signal back to the Milky Way. That signal would need more than 2 million years to return. By the time it arrived, the civilization that launched the probe might be unrecognizable or gone. The data would be ancient before anyone received it. And if the receiving civilization sent a reply, the probe would wait millions of years for instructions. There can be no real time control across galaxies. No mission team guiding every decision. No immediate correction. No conversation. The probe must think alone. This is one of the deepest differences between exploring planets and exploring galaxies. A rover on Mars can receive commands after a delay of minutes. A probe near Saturn communicates after more than an hour. A spacecraft at the edge of the solar system may require many hours for signals to travel. But between galaxies, delays become longer than the age of civilization. The connection breaks not technically, but historically. Communication is still possible in physics, but it loses the emotional meaning of contact. A message crossing intergalactic space is less like a phone call and more like a sealed monument launched into time. This may also affect the search for extraterrestrial intelligence. When we think of alien civilizations, we often imagine signals crossing the stars. But intergalactic signals are far more difficult. A civilization in another galaxy could be broadcasting powerful messages, and those messages would still take millions of years to arrive. If their technology existed for only a few thousand years, we would need to be looking in exactly the right era. A signal might pass Earth before humans build receivers, or it might arrive millions of years after we are gone. The problem is not only distance, it is synchronization. Two civilizations must exist at the right times. Their signals must cross the right directions. The signals must remain strong enough to detect. The receiving civilization must recognize them as artificial. Across galactic distances, even a universe full of intelligent life could appear silent. The silence may not mean absence. It may mean separation. Separated by distance, separated by time, separated by horizons, separated by the limits of signal strength. This is why the spaces between galaxies feel almost cruel. They allow vision, but deny conversation. We can see Andromeda, but we cannot know what is happening there now. We can see galaxies billions of light years away, but we see their ancient light, not their current condition. We can detect cosmic history, but we cannot easily participate in it. The universe is visible in ways it is not reachable. A telescope can collect photons that cross the abyss. A spacecraft cannot easily follow them. Light is the great traveler. Matter is slow. This difference shapes everything we know. Astronomy exists because light comes to us. Space exploration is difficult because matter must go out. The light from a distant galaxy arrives freely, silently, across millions of years. A spacecraft trying to make the same journey must carry structure, fuel, power, memory, and protection. A photon does not need food. It does not need repairs. It does not age in the way a machine does. It simply follows the geometry of space-time until it interacts. That is why the universe can be observed across unimaginable distances long before it can be physically crossed. We are rich in sight and poor in reach. This is one of the most beautiful and painful truths of astronomy. We can know that distant galaxies exist. We can map their shapes, measure their redshifts, estimate their masses, Study their stars, detect their black holes, watch them merge, observe them when they were young. But reaching them remains almost impossible. Knowledge travels farther than bodies. Perhaps this will always be true. Perhaps intelligence is not meant to cross the entire universe physically. Perhaps the universe is built in such a way that most civilizations can learn about distant galaxies, but never touch them. They may become astronomers rather than conquerors, witnesses rather than travelers. This does not make the knowledge less valuable. It may make it more precious. Because every photon from another galaxy is a successful crossing of an impossible distance. Every image of a distant cluster is a message from a place we may never visit. Every measurement is a bridge made of light. The space between galaxies also contains material that most people never imagine. It is not perfectly empty. The intergalactic medium contains gas, much of it extremely thin and often very hot. In clusters, this gas can reach temperatures of millions of degrees. It emits X-rays. It can contain more ordinary matter than the galaxies themselves. This means a galaxy cluster is not only a collection of galaxies, it is also an enormous atmosphere of thin plasma spread across millions of light years. Galaxies move through it. Their gas can be stripped away by pressure as they travel. The process can leave long tails of material trailing behind them. A spiral galaxy entering a cluster may lose the cold gas it needs to form new stars. Over time, it can become quieter and redder. The cluster environment changes galaxies. It can starve them, distort them, transform them. Distance does not mean isolation inside clusters. Gravity and gas connect the members, but in the wider spaces between clusters, the gas becomes thinner. Some of it lies in filaments connecting galaxy groups. Some may be warm and difficult to detect. Astronomers have searched for missing ordinary matter believed to exist in these diffuse structures. The cosmic web is not only visible galaxies. It includes gas spreads so thin that detecting it requires careful observation. Much of the universe's ordinary matter may exist in forms far less dramatic than stars, not glowing brightly, not forming planets, just thin material stretched through intergalactic space. This gas may one day fall into galaxies or clusters, or it may remain diffuse. It is part of the ongoing exchange between structure and emptiness. A galaxy is not a closed box. Gas flows in, stars form, supernovae push material out, black holes heat surrounding gas, mergers redistribute matter. Galaxies breathe across cosmic time. The space between them is part of that breathing. This makes the universe feel more connected than it appears. Galaxies are separated by enormous distances, but they are not entirely independent islands. They lie inside dark matter halos. They belong to groups and clusters. They move along filaments. They exchange gas with surrounding space. They respond to gravity from structures far beyond their visible edges. The Milky Way itself is still absorbing smaller galaxies. Streams of stars around it show where past companions were torn apart. The galaxy grows through interaction. Andromeda has done the same. Even isolated galaxies carry histories of encounters. The universe is both isolated and connected. Objects are separated by distances that prevent easy travel. Yet gravity links them across those distances. Light carries information. Gas moves through large-scale structures. Dark matter shapes the invisible landscape. A galaxy may be millions of light years away and still be part of the same gravitational story. This paradox is central to the cosmic web. The universe is not a collection of disconnected points, nor is it a solid network where everything is nearby. It is a structure connected by forces but separated by immense time. The connections exist. They simply operate slowly. Gravity does not need objects to touch. It shapes motion across distance. A cluster can pull on galaxies over millions of light years. A supercluster can influence flows across even larger regions. The Milky Way's motion is affected by surrounding matter we cannot see directly. The local group moves relative to the cosmic microwave background because of the combined gravitational influence of distant structures. We are not floating randomly. We are flowing through a gravitational landscape. But the flow is slow compared with the scale. That is the cosmic contradiction. Everything moves. Everything changes. But the universe is so large that movement feels frozen. If we could watch millions of years pass in seconds, galaxies would drift along filaments. Clusters would gather. Small galaxies would fall into larger ones. Voids would grow emptier. The cosmic web would evolve like a living pattern. But at human speed, it looks almost still. This is why our minds underestimate distance. We see a galaxy in a photograph and treat it as an object. We do not feel the millions of years encoded in its light. We see a cluster and think of a group. We do not feel the vastness between each member. We see a deep field and think the universe is crowded. We do not see the layers of time stacked behind the image. Images make the universe emotionally smaller. Understanding makes it larger again. Consider the Coma cluster. It lies hundreds of millions of light years away. It contains thousands of galaxies. In a telescope image, it may appear like a rich field of bright points and soft ellipses. But every one of those galaxies is separated from the others by enormous distances. And the cluster itself is so far away that the light reaching us began its journey long before humans existed. If intelligent life existed in one of its galaxies and looked toward the Milky Way, it would see our galaxy as it was hundreds of millions of years ago. Earth would not show humans. It would not show modern continents. It would be a completely different biological world. Intergalactic observation is not mutual present awareness. It is an exchange of ancient appearances. The farther the distance, the older the view. This creates a universe where every observer is surrounded by ghosts. Not supernatural ghosts, physical ghosts made of light. Galaxies as they were, stars as they were, explosions that happened long before the signal arrived. The night sky is an archive, not a live broadcast. The deeper we look, the older the archive becomes. Between galaxies, the archive is stretched across distances so large that reality becomes historical. We do not see the cosmic web as it is right now. We see many versions of it from different times. Nearby structures appear relatively recent. Distant structures appear younger. The farthest galaxies appear in the early stages of cosmic history. A single image of the universe contains multiple eras at once. This is another reason the distance between galaxies is worse than it appears. Distance does not only separate places, it separates times. Two galaxies in the same image may not be seen in the same cosmic age. A nearby galaxy may be shown in a mature universe. A distant one may be shown when the universe was young. Our eyes and cameras flatten them together, but physics keeps them apart. The farther we travel in observation, the more space becomes time. This is why the expansion of the universe matters so much. As light travels, space stretches. The light stretches with it. Its wavelength grows longer. This is cosmological redshift. A galaxy's light becomes redder as the universe expands during the journey. For very distant galaxies, light originally emitted in ultraviolet or visible wavelengths may arrive in infrared. Without instruments that can detect those wavelengths, we would miss them. The universe hides distant objects not only by making them faint, but by shifting their light beyond human vision. Some galaxies are not invisible because they stop shining. They are invisible to our eyes because their light has been stretched. Again, distance changes reality. The galaxy emits one kind of light. The expanding universe delivers another. By measuring redshift, astronomers estimate how much the universe expanded while the light traveled. This allows them to map distance and history. But it also reveals the scale of the problem. Many galaxies are not merely far away. They are embedded in a universe whose geometry has changed during the light's journey. The distance when the light was emitted was not the same as the distance now. The distance the light traveled is not always the same as the current separation. Cosmic distance has several meanings: light travel distance, comoving distance, proper distance at emission, proper distance today. Each describes a different aspect of the same relationship. This complexity would be unnecessary if the universe were a static stage. But it is not. Space itself evolves. At everyday scales, we can ignore this. The distance between cities does not expand with the universe. The distance between Earth and the Moon is controlled by local gravity and tidal effects. The distance between stars inside the Milky Way is governed by the galaxy's gravity. But between distant, unbound galaxies, cosmic expansion becomes essential. The stage itself changes while the actors move. A ship crossing an ocean can measure distance through water that behaves relatively stable on human timescales. A photon crossing the universe moves through a space-time whose scale changes during the trip. This is why some galaxies become unreachable. Imagine trying to walk toward a destination while the ground between you and the destination stretches faster than you can cover it. Locally, you keep walking normally, but the total distance still increases. At cosmic scales, light can face a similar situation with sufficiently distant regions. This does not violate the speed of light because nothing locally outruns light through space. The expansion of space changes the distance itself. This is one of the most difficult truths to visualize, but it is central to understanding intergalactic distance. The abyss is not only wide, it is dynamic. It changes with time. A galaxy visible today may fade from future observation. Its light will become weaker and more redshifted. Eventually, it may disappear beyond detectability. The future universe will not display the same sky. Distant galaxies are slowly leaving the stage of our accessible reality. The Milky Way and its bound neighbors will remain, but the far cosmic web will retreat. The universe will become lonelier, not because galaxies vanish locally, but because their signals can no longer reach us in useful form. This future gives today's observations a sense of urgency. We live during a time when the great distances between galaxies can still be studied richly. The cosmic microwave background remains visible. Distant galaxies still fill deep field images. Galaxy clusters and filaments can still be mapped. The evidence of the larger universe surrounds us. But in the far future, the same region of space may look almost empty beyond the merged local group. A civilization born then might not know what we know now. It might lack the observational evidence to reconstruct the full cosmic web. It might see only its local galaxy and assume that is all. The universe does not guarantee that every era has equal access to truth. Knowledge depends on cosmic timing. Humanity exists during a rare window, late enough for rocky planets and life, early enough to see the wider universe. This makes the distance between galaxies both terrifying and generous. Terrifying because it prevents travel. Generous because light still crosses it. The galaxies are far, but not yet all hidden. The voids are vast, but not silent. The cosmic web is enormous, but not unknowable. We can map it from one small planet. We can measure motions across hundreds of millions of light years. We can detect ancient radiation from the early universe. We can understand that the galaxies in our sky are not decorations, but distant histories. And perhaps that is the only kind of intergalactic journey we will ever truly make, not by crossing the abyss physically, but by receiving what the abyss allows to pass. Light, gravity, radiation, signals from events long gone. The universe may keep its galaxies separated, but it still lets them tell their stories. The next part of the journey takes us into the most extreme spaces of all. The cosmic voids, regions so empty that galaxies become rare accidents. Places where darkness dominates not just the sky, but the structure of space itself. And there, between the filaments of the cosmic web, we begin to understand something even more unsettling. The distance between galaxies is terrible, but the distance between the structures that contain galaxies may be worse. Beyond the galaxy clusters, beyond the filaments, beyond the bright knots, where thousands of galaxies gather together, the universe opens into its most silent regions. The cosmic voids. These are not small, empty pockets between stars. They are not gaps between neighboring galaxies. They are immense regions of space where galaxies become rare, where matter is thinly spread, and where the universe seems to have stepped back from itself. Some voids are tens of millions of light years across. Others may stretch hundreds of millions of light years from one side to the other. To cross such a region, even light needs an amount of time longer than the entire history of complex life on Earth. From a distance, a cosmic void may appear as a dark gap in the web of galaxies. But if we could enter one, the emptiness would become something more than darkness. It would become a scale, a silence so large that ordinary ideas of location would begin to fail. In a galaxy, there are stars. In a galaxy cluster, there are many galaxies. In a cosmic filament, there is a long road of matter connecting one dense region to another. But inside a void, there may be almost nothing nearby to use as a landmark. A spacecraft traveling there would not see galaxies rushing past. It would not see bright stars surrounding it. It would not pass planets, moons, or glowing nebulae. It would move through an enormous volume where the nearest major galaxy could be millions of light years away. The sky would still contain distant light. The universe would not be completely black, but everything would be far away. Every visible galaxy would look like a remote island. Every destination would feel less like a place to reach and more like a memory suspended in darkness. This is where the distance between galaxies becomes more terrifying than the galaxies themselves, because galaxies are already separated by impossible spans. But the voids reveal that even galaxies belong to larger separations. A galaxy is not merely far from another galaxy. It may lie on the edge of a structure, surrounded by empty volumes vastly larger than itself. The cosmic web is made of matter and absence together. The bright parts capture our attention, but the dark parts occupy much of the space. In a deep field image, the universe looks crowded. Thousands of galaxies fill a tiny region of sky. But that image is a projection. It stacks different distances and different eras into one flat view. If we could unfold the image into real three-dimensional space, the galaxies would separate into layers. Some would be nearby, some would be far behind them. Some would belong to ancient cosmic history. Between those layers, the volume would open, and the apparent crowding would dissolve into distance. This is the illusion that makes the universe seem easier to cross than it is. Images give us galaxies without the travel time. They show us light without the abyss the light had to survive. A spiral galaxy may appear beside another in a picture, but the two may be separated by millions or billions of light years. They may not belong to the same cluster. They may not belong to the same era. One may be seen as it was when the universe was younger, while the other is seen much closer to the present. The sky puts them together. Reality keeps them apart. Inside a void, that separation becomes clear. The nearest galaxies would no longer feel like nearby structures. They would become distant lamps across an ocean that cannot be crossed by any ordinary civilization. A human mind might search for patterns, a familiar constellation, a bright galactic neighbor, a direction that feels like forward. But intergalactic emptiness gives almost nothing back. It does not help the traveler feel progress. It does not provide scale in a human way. It simply continues. This is what makes the void so different from the spaces inside galaxies. Interstellar space is already empty, but it still belongs to a galaxy. The stars around you may be far apart, but there are stars. The galaxy gives a background structure. It gives a destination, a center, a disk, a halo, a sense of belonging to a larger system. Intergalactic voids remove that comfort. There is no galactic disk surrounding the traveler, no spiral arm, no local neighborhood of stars, no home galaxy filling half the sky, unless the traveler has not yet gone too far. There is only the immense scale of the universe itself. If a spacecraft entered a large void after leaving a filament, the galaxy it came from would slowly fade behind it. At first, the original structure might still dominate the view, a cluster of galaxies behind the ship, a thread of cosmic web glowing faintly across one region of the sky. Ahead, another structure might be visible, but impossibly distant. The ship would travel toward it for years, then centuries, then thousands of years. And to any human passenger, the destination would barely change. The galaxy ahead might become slightly brighter over many generations. The cluster behind might become slightly smaller. But the change would be so slow that life aboard the ship would feel disconnected from the journey. This is why crossing a void would be one of the most psychologically impossible forms of travel. Humans evolved in environments where movement produces feedback. Walk through a forest and trees pass beside you. Cross a desert and dunes change. Sail across an ocean and waves move, clouds shift, stars rise, storms form. Even in space near a planet, the destination can grow in the window. But in a void, the universe offers almost no visible reward. A civilization aboard a generation ship might spend thousands of years with the same faint galaxies in the same distant positions. Children would be born, grow old, and die, while the sky remained almost unchanged. The mission would become faith, not necessarily religious faith, but cultural faith, a belief that the ship is moving towards something meaningful, even when no individual life can witness real progress. At that scale, exploration becomes difficult to separate from mythology. A destination chosen by ancestors becomes a sacred direction. Navigation records become historical scripture. The original planet becomes a legend. The galaxy behind becomes an origin story. The void outside becomes the surrounding eternity. This is not science fiction as much as a consequence of scale. When travel lasts longer than memory, the purpose of the journey must be preserved somehow, through records, education, ritual, law, architecture, artificial worlds inside the ship. But every system can change. Languages drift, values shift, populations adapt. The mission imagined at launch may not be the mission understood a million years later. This is why intergalactic distance may defeat not only technology, but identity. A ship might survive physically and still lose the reason it began. A civilization might arrive somewhere its ancestors selected, but no longer care why. Or it might choose to stop long before reaching the original destination. Perhaps it finds a rogue star. Perhaps a small galaxy crosses its path. Perhaps survival matters more than arrival. At cosmic scales, the shortest route is not always the meaningful route. A civilization crossing a void may eventually become its own destination. The ship becomes the world. The journey becomes the culture. The galaxy ahead becomes only a direction in ancient maps. Robotic probes avoid this psychological problem, but not the physical one. A probe crossing a void must survive durations that make ordinary engineering meaningless. Even if it travels at a fraction of the speed of light, the crossing of a large void could take hundreds of millions of years depending on the route. A machine lasting that long would need to resist erosion from particles, cosmic rays, rare dust impacts, internal degradation, and the decay of its power systems. It would need to store data for spans far longer than any human archive has survived. It would need to make decisions without expecting a response from its creators. A probe in a void cannot be remotely controlled. Any message sent from home would take millions of years to arrive. Any reply would take millions more to return. The probe is alone in every practical sense. It must interpret the universe by itself. If it detects a target, it must decide whether to investigate. If its systems fail, it must repair them. If its memory corrupts, it must rebuild truth from redundancy. If its path shifts because of unseen gravitational influences, it must correct course. Such a probe would be less like a tool and more like a long-lived artificial explorer. It might outlast its makers. It might preserve information about a civilization whose planet has changed beyond recognition. It might send back a signal that no one is there to receive. Or perhaps the signal arrives, but the receiving civilization no longer understands the format, the language, or the purpose. The distance between galaxies turns communication into archaeology. A message is not a conversation. It is an artifact, a piece of one age arriving in another. This applies not only to spacecraft, but also to alien civilizations. If intelligent life exists in a galaxy across a void, the time delay would be enormous. Suppose a civilization there sends a message in our direction. The signal travels through intergalactic darkness. It passes through regions of thin gas and dark matter. It crosses expanding space. It may take tens or hundreds of millions of years to arrive. By the time we detect it, the civilization that sent it could be gone. Its star may have changed. Its planet may have transformed. Its language may have vanished. And if we reply, our answer would arrive in their far future, if it arrives at all. The two civilizations would never truly meet. They would exchange fossils of thought across time. This makes the search for life beyond our galaxy deeply strange. There may be life in distant galaxies. There may be intelligence. There may be worlds with oceans, cities, machines, histories, and questions similar to ours. But distance ensures that most of it may remain permanently unreachable. Not because it is hidden, not because it is rare, but because the universe is too large for ordinary contact. The silence between galaxies may not be empty silence. It may be a silence created by delay, signals too faint, messages too old, civilizations not aligned in time, whole histories missing each other by millions of years. A galaxy could shine with life and still appear to us only as a spiral of unresolved light, its individual worlds hidden, its voices blended into distance, its presence unknowable. When we look at Andromeda, we do not see any possible civilizations there as they are now. We see the galaxy more than 2 million years in the past. If there is life there today, its current light has not reached us. If there was intelligence there 2 million years ago, we would still struggle to detect it from so far away, unless it produced signals of extraordinary power. A city does not brighten a galaxy enough to be seen across intergalactic distance. A planet does not announce itself easily from millions of light years away. At that scale, individual stories disappear into collective light. This may be the greatest tragedy of cosmic distance. The universe may contain countless stories, but from far away they become statistics. A galaxy becomes mass, brightness, redshift, shape, star formation rate, metallicity, black hole activity. All of these are powerful scientific clues, but they do not reveal the lives inside. A world with oceans becomes one invisible point. A civilization becomes undetectable noise. 1 million years of history becomes a fraction of the light from one spiral arm. Distance does not only make travel hard, it erases detail. The farther we look, the more the universe becomes generalized. Nearby, we can study planets. Farther away, we study stars. Farther still, galaxies. Farther still, clusters. At the greatest distances, we study the universe as a whole. Each step outward sacrifices detail for scale. This is why the distance between galaxies is so important. It marks a boundary where individual worlds vanish from view. A galaxy may contain hundreds of billions of stars, but from far away it becomes a single object. The internal richness remains real, but inaccessible. This is what would happen to the Milky Way if seen from a distant galaxy. Earth would not be visible. The sun would not be noticeable. Humanity would not appear. All of our wars, inventions, languages, love, grief, music, and curiosity would be hidden inside one faint spiral structure. From outside, the Milky Way would be beautiful and silent. No one could tell that a species inside it had once asked how far away the next galaxy was. This realization should not make us feel meaningless. It should make us careful. Meaning does not depend on being visible from far away. A whisper is not meaningless because a galaxy cannot hear it. A life is not empty because a telescope cannot resolve it. Scale and value are different things. The universe can be enormous while local experience remains real. But astronomy forces humility. It shows that our visibility is limited, our reach is small, our moment is brief. And still, from this small position, we can understand the structure of distances that may forever prevent us from crossing them. This is one of the most remarkable things about the human mind. We cannot travel to the Virgo cluster, but we can measure its distance. We cannot cross a cosmic void, but we can map its shape. We cannot speak with Andromeda in real time, but we can know its light has traveled for millions of years. We cannot see beyond every horizon, but we can understand why horizons exist. Knowledge is not the same as possession. We do not need to own the universe to understand parts of it. The voids reveal this clearly. They are inaccessible in any practical sense, yet we know they exist because galaxies avoid them. Their emptiness becomes visible through the pattern around them. A void is detected not as a glowing object, but as an absence in the distribution of light. The universe tells us where matter is by showing us where it is not. This is similar to the way dark matter reveals itself through gravity. Some of the most important things in cosmology are not seen directly. They are inferred through effects. Motion, missing light, distorted paths, empty regions. The universe is understood not only by what it shows, but by what it withholds. A cosmic void is one of the greatest examples of withheld presence. It is not an object. It is a region where objects are rare, yet it shapes the cosmic web. As voids grow, matter flows toward filaments and clusters. The empty regions expand relative to dense regions. They push the large-scale structure into sharper contrast. Over time, the universe becomes more web-like. Dense regions become denser. Voids become emptier. Gravity and expansion work together to separate the cosmos into islands and absence. This means the future universe will be even more isolated. The local group will remain gravitationally bound. The Milky Way and Andromeda will merge. Smaller galaxies nearby will be absorbed or continue orbiting. But outside this bound region, cosmic expansion will carry distant structures away. The voids between us and other superclusters will grow in practical importance. Galaxies we see today will become harder to detect. Their light will stretch toward longer wavelengths. Their brightness will fade. Eventually, many will disappear beyond the cosmic horizon. A far future observer in our merged galaxy may look outward and see very little beyond local stars. The universe that appears rich to us may appear nearly empty to them. They may not see the Virgo cluster. They may not see the deep cosmic web. They may not detect the same background evidence as easily. Without ancient scientific records, they might believe their galaxy is alone. This is a strange thought. The truth of the universe may become harder to discover with time. We live during an age when the cosmic distances are enormous but still visible. The galaxies are far away, but their light still reaches us. The cosmic microwave background still fills the sky. Large-scale structure can still be mapped. Expansion can still be measured. Our era is not special because we are at the center. We are not. It is special because we can still see enough to know we are not alone in the cosmic web. In the far future, distance will hide what distance currently reveals. That makes today's astronomy precious. Every image of distant galaxies is a record of a universe that will not always be equally visible. Every deep field is a preservation of cosmic history. Every measurement of redshift is a clue from an era when the universe still allowed connection through light. The distances are terrible, but they have not yet closed every window. This also changes the meaning of the word observable. The observable universe is not everything that exists. It is the region from which light has had time to reach us since the beginning of cosmic history. Beyond that, there may be more galaxies, more voids, more filaments, perhaps far more universe than we can ever see, but those regions are outside our current horizon. Some may become visible in the future as their light arrives. Others may never become visible because expansion prevents their signals from reaching us. The boundary is not a wall, it is a limit of information. This means the universe may contain distances even worse than the ones we can measure. The largest structures we see may be only part of a much larger reality. The cosmic web may continue beyond our horizon. Or space may be finite in a way that has no edge. Or the observable region may be one small patch of something far greater. We do not know the full answer, but we do know this. The distances already visible are enough to challenge every ordinary idea of travel. If the nearest major galaxy is millions of light years away, and clusters lie tens or hundreds of millions of light years away, and the observable universe stretches across tens of billions of light years in every direction, then physical exploration across the cosmos is not merely difficult. It may be permanently limited. Civilizations may rise inside their own galaxies, learn about the wider universe, and still remain trapped within local regions. They may send probes to nearby stars. Perhaps they spread across parts of a galaxy. Perhaps very advanced civilizations cross intergalactic gaps within a local group. But the entire universe may remain beyond the reach of any single civilization. Expansion, time, and distance divide reality into accessible and inaccessible regions. There may be no empire of the whole cosmos, no civilization that visits every galaxy, no final map completed by travelers. The universe may be too large to be physically known in that way. This does not mean exploration ends. It means exploration changes form. We may explore nearby worlds with machines. We may explore stars with future spacecraft. We may explore galaxies with telescopes. We may explore the early universe through ancient light. We may explore physical laws through mathematics. Understanding becomes the method of crossing what bodies cannot cross. Astronomy is a kind of travel performed by light and thought. A photon leaves a galaxy. It crosses a void. It enters a telescope. A mind reconstructs where it came from. In that moment, a small part of the distance is defeated, not by movement of matter, but by interpretation. The universe gives us evidence, and we learn how to read it. This is why the distance between galaxies, though terrifying, is also beautiful. It prevents contact, but preserves history. The longer light travels, the older the story it carries. A distant galaxy is not only far away, it is a time capsule, a record of how galaxies formed, evolved, collided, and changed across cosmic history. If all galaxies were close, the universe would not show us its past in the same way. Distance creates the archive. The same barrier that separates us also allows us to see time. This is one of the great paradoxes of cosmology. The universe is inaccessible because light takes so long to travel, but it is understandable because light takes so long to travel. The delay is both obstacle and gift. We cannot see Andromeda as it is now, but we can see Andromeda as it was before human civilization existed. We cannot visit young galaxies billions of light years away, but we can observe their early stages. We cannot reach the cosmic microwave background, but we can detect light from when the universe first became transparent. Distance turns space into history, and history gives meaning to distance. So when we say the distance between galaxies is worse than you think, we are not speaking only about kilometers or light years. We are speaking about delay, isolation, expansion, lost detail, unreachable horizons, messages that take longer than civilizations, journeys that outlast species, galaxies that are visible but cannot be visited, civilizations that may exist but never speak, voids so large that even clusters seem like temporary islands along the edge of darkness. This is the true scale of the universe, not a crowded night sky, not a collection of nearby spirals, not a map where bright dots sit close together, but an expanding structure where matter gathers into luminous islands separated by oceans of time. The Milky Way is one island. Andromeda is another. Virgo is a greater archipelago. The cosmic web is the chain of all these islands, and the voids are the dark waters between them. From Earth, we see the lights. We do not feel the crossings. But every photon arriving from another galaxy has already completed a journey no human spacecraft may ever repeat. That photon crossed the darkness without fear, without memory, without destination. It simply traveled, and when it reached us, it became part of our understanding. Perhaps that is enough for now. Perhaps the purpose of our age is not to cross the universe physically, but to recognize its scale while we can still see it, to understand that the galaxies in the sky are not close, that the darkness between them is not empty in a simple way. That distance is a form of time, that the visible universe is only the reachable past of light, and that our home galaxy, enormous as it feels, is only one small structure inside a reality far beyond human scale. The distance between galaxies is worse than we imagined, but knowing that does not make the universe less wonderful. It makes every point of light more meaningful. Every faint galaxy becomes a messenger. Every deep field becomes a map of ancient journeys. Every dark gap becomes part of the architecture of existence. And when we look into the night sky, we are not seeing a ceiling of stars. We are seeing distances so vast that even light becomes ancient before it arrives. Somewhere beyond the Milky Way, Andromeda continues moving toward us. Beyond Andromeda, clusters drift through the cosmic web. Beyond the clusters, voids expand in silence. Beyond the voids, more galaxies shine with light that may never reach every observer. The universe continues outward. Or perhaps it curves. Or perhaps it extends without end. We do not know. But we know enough to understand this. Galaxies are not close together. They are separated by the deepest kind of distance. A distance made of space. A distance made of time. A distance made of silence. And across that silence, light travels for millions and billions of years just to let us know that something is there. There is one final reason the distance between galaxies feels almost impossible to accept. It is not only because galaxies are far away. It is because they are far away in a universe that is still changing. If the universe were frozen, if every galaxy simply waited in place like a distant island, then distance would be a brutal problem. But at least it would be a fixed problem. A civilization could imagine building faster ships, longer-lasting probes, more powerful telescopes, better communication systems. The destination would remain where it was. The map would stay the same. But the universe does not wait. The space between distant galaxy groups continues to expand. The cosmic web evolves. Voids grow. Clusters remain bound, but the regions between them stretch farther apart. Light from some galaxies continues reaching us today only because it began traveling when those galaxies were much closer than they are now. Their images remain in our sky like messages from a universe that no longer has the same shape. This means the distance between galaxies is not simply an obstacle across space. It is an obstacle across time. A galaxy may appear reachable in a photograph because its light is here, but the galaxy itself has continued moving through cosmic history. The space between us and it has changed. Its stars have aged. Its gas has shifted. Its planets, if it has them, have lived through millions or billions of years that we cannot see yet. We do not observe the present of the distant universe. We observe layers of its past. This is why a deep field image can be so misleading and so beautiful at the same time. It shows thousands of galaxies, but it does not show them sharing one moment. It shows a stack of histories. Nearby galaxies from a relatively recent age. more distant galaxies from a younger universe, extremely distant galaxies from an era before the Sun existed, all placed into one image because their light arrives together at our telescope. The picture looks like a map, but it is also a timeline. Every galaxy in it belongs to a different depth of space and a different age of the universe. If a spacecraft could somehow begin traveling toward one of those distant galaxies, it would not enter the image, it would enter the future. The galaxy in the photograph is gone as that version of itself. The light shows what it was. The journey would seek what it has become. This simple difference changes everything. Astronomy is the study of arrivals. Travel is the pursuit of what remains after the light has left. The farther the galaxy, the greater the separation between what we see and what exists now. A galaxy 100 million light-years away is seen 100 million years in the past. A galaxy 1 billion light-years away is seen 1 billion years in the past. Some galaxies visible to powerful telescopes are seen when the universe was only a small fraction of its current age. They may no longer look anything like the faint red shapes we observe. They may have merged with neighbors, lost gas, formed new stars, fed their central black holes, changed from chaotic young structures into mature galaxies, or become part of clusters that did not yet exist in the same form when their light began traveling. The universe is alive with transformation, but we receive its transformations delayed. So the distance between galaxies does something strange. It turns space into memory. Every photon from another galaxy carries evidence from a place we may never reach and a time we cannot enter. It is not only a messenger from far away, it is a messenger from long ago. This means the night sky is not a live view of the universe. It is an archive, and like every archive, it is incomplete. It contains what survived the journey. It contains light bright enough to be detected. It contains signals not blocked, absorbed, stretched beyond recognition, or lost in the noise. But it does not contain everything. It cannot show every planet. It cannot reveal every ocean. It cannot preserve every civilization, if civilizations exist elsewhere. It cannot tell us every event happening now. The farther away we look, the more reality becomes simplified. At close range, a planet can be a world. We can study its surface, atmosphere, moons, and weather. At greater distance, a star becomes a point. At greater distance still, an entire galaxy becomes a soft patch of light. Hundreds of billions of stars are blended into one shape. Everything inside it becomes hidden by scale. A solar system disappears into a star. A star disappears into a galaxy. A life disappears into statistics. This is one of the quietest but most devastating effects of intergalactic distance. It does not only delay information, it erases detail. From far enough away, Earth is not a world of oceans, forests, deserts, cities, and voices. It is not even a visible planet. It is part of the light of the sun. From farther still, the sun is only one point in the Milky Way. From another galaxy, even the sun disappears into the collective glow of hundreds of billions of stars. Humanity becomes invisible, not because it is meaningless, but because distance removes resolution. The same must be true in the other direction. Andromeda may contain planets. Some may have oceans. Some may have moons. Some may have chemistry as complex as Earth's. There may be worlds there, where storms move across alien seas, where mountains rise under unfamiliar constellations, where life has appeared in forms we cannot imagine. There may be nothing living at all. We do not know. But from Earth, Andromeda is mostly light, a galaxy. a structure, a mass, a motion, a future merger partner. Its inner details are beyond our direct reach. That is the tragedy and beauty of galaxies. They may contain almost endless stories, but from across intergalactic space, they become silent shapes. A spiral arm might contain billions of worlds. A bright knot might contain thousands of young stars. A dark dust lane might hide systems forming in cold clouds. But the telescope receives the combined light, not the individual experience. Distance compresses reality into appearance. If another civilization in Andromeda were looking at the Milky Way, the same would happen. They would not see our present world. They would see the Milky Way more than 2 million years ago. Earth would be in a prehistoric age. No human cities, no satellites, no radio broadcasts from our civilization reaching them yet. The light from our modern world has not had enough time to cross the gap. To them, if they could even isolate our sun, Earth's current chapter would be completely unknown. And if we tried to send a message now, it would arrive in their far future. The distance between galaxies destroys shared time. Two civilizations can exist in the same universe and still never meet in a meaningful present. They may see one another only as ancient traces. A signal could arrive long after the sender has changed or vanished. A reply could return to a world that no longer remembers asking. This is why intergalactic contact would be closer to archaeology than conversation. A message across galaxies is a fossil made of light. It travels through darkness. It preserves intention, but it cannot preserve the living moment that produced it. By the time it is found, the sender belongs to history. This possibility makes the cosmic silence more complicated. If we do not hear voices from other galaxies, it does not prove they are empty. The signals may be too weak. The timing may not overlap. The messages may not be directed toward us. The civilizations may use technologies we do not recognize, or they may exist in eras that miss ours by millions of years. The universe may be full of intelligence and still appear silent across intergalactic distances. Not because no one speaks, because the room is too large, because every voice takes too long to arrive, because the listeners may not exist at the same time. This does not make life less possible. It makes connection more fragile. Even within the Milky Way, distances between stars are already difficult. But within one galaxy, there is at least a shared gravitational home. A civilization might imagine spreading from star to star over immense time. It might send probes. It might build networks. It might learn to live across many systems. The distances are severe, but the galaxy remains one structure. Between galaxies, the scale changes again. The gap between the Milky Way and Andromeda is far greater than the distance between nearby stars. And beyond our local group, cosmic expansion begins to separate unbound structures more and more strongly. The far universe is not merely distant, it is becoming inaccessible. This introduces the most haunting idea of all. There are galaxies we can see today that no traveler leaving now could ever reach. Not with any ordinary technology, not even with a signal moving at the speed of light. Their old light reaches us because it began its journey long ago, when conditions were different. But the current distance and the expansion of space place them beyond future contact. They are visible memories of regions that are already causally lost to us. The universe shows us places that it will never allow us to touch. This is not a wall. There is no physical barrier in the darkness, no edge where a spacecraft crashes into a boundary. The separation is created by space-time. the distance grows faster than future signals can overcome. A beam of light sent towards some distant galaxies today would travel faithfully at light speed through its local region, but the total path would stretch beyond its ability to arrive. The light would never reach the target. The target's future light would never reach us. The two regions would slip outside each other's possible future. This means the universe is divided not only by what is far, but by what can ever influence what. The observable universe is the region from which light has reached us. The reachable universe is smaller. The future visible universe will change. Some lights now arriving will fade. Other signals may arrive from regions just now entering our horizon, but accelerating expansion creates a long-term separation that grows more severe with time. The cosmic web we see today will not remain equally accessible forever. The local group will stay bound. The Milky Way and Andromeda will merge. Nearby dwarf galaxies may be absorbed. A new, larger galaxy will eventually dominate our local environment. But outside this gravitational island, distant galaxy groups will retreat beyond practical reach. Their light will stretch. Their images will dim. Their presence will fade from the skies of future observers. One day, if intelligence still exists in the far future, it may look outward and see only the local merged galaxy surrounded by darkness. The grand cosmic web may be hidden. The deep fields that show thousands of galaxies may no longer be possible in the same way. The universe will not have become empty everywhere. It will have become observationally isolated from that future location. That future is unsettling because it means cosmic knowledge depends on when you live. We often imagine science as a steady climb toward more information, but the universe does not promise that all evidence remains available. Some evidence appears only during certain eras. We live at a fortunate moment, late enough for heavy elements, rocky planets, oceans, life, and consciousness. Late enough for galaxies to be mature and beautiful, but early enough that distant galaxies are still visible. Early enough that the cosmic microwave background still fills the sky. Early enough that expansion can be measured through the recession of galaxies. Early enough that the universe still reveals its large-scale history. In the far future, much of that evidence may be gone or extremely difficult to detect. A civilization born then could misunderstand the universe, not because it lacks intelligence, but because the universe has hidden the clues. It may believe its galaxy is nearly alone. It may not easily discover the Big Bang. It may not see the same rich cosmic web. The truth may still exist, but the evidence may be weaker. This is one reason our current view matters. Every deep image of galaxies is not only a scientific achievement. It is a record taken during an era when the universe can still show us its scale. Every redshift measurement, every map of galaxy clusters, every detection of the cosmic microwave background, every observation of distant young galaxies, all of these are pieces of evidence gathered before distance and time make them harder to see. We are not simply studying the universe. We are documenting a temporary window of cosmic visibility. That gives the distance between galaxies a strange tenderness. The same distance that makes travel nearly impossible also allows ancient light to arrive. The same delay that prevents live communication allows us to see the past. The same vastness that isolates galaxies also preserves their history in the sky. If galaxies were close together, light would not carry such ancient memories. If the universe were small, looking outward would not reveal billions of years of development. The distance is terrible, but it is also the reason astronomy can become time travel of sight. A telescope cannot move us physically across the void, but it can receive light that has already crossed it. That light becomes a bridge. Not a bridge for bodies, a bridge for information. A photon from a distant galaxy leaves a star, a gas cloud, or the region around a black hole. It travels through expanding space. Its wavelength stretches. It passes near other galaxies, perhaps bending slightly under their gravity. It continues through darkness for millions or billions of years. It enters the Milky Way. It crosses the solar system. It reaches a mirror or a detector, and in that moment, a small piece of another galaxy becomes part of a mind on Earth. That is extraordinary. No spacecraft made the journey. No astronaut crossed the gap. No civilization built a road. But the universe delivered a message. Astronomy is built from these messages. It is the art of listening to light that has survived impossible distances. It is the science of reconstructing places we may never visit. This may be the only way any civilization can know the larger universe. Not through conquest, not through travel to every galaxy, but through observation, patience, and interpretation. Perhaps intelligent life, wherever it appears, must learn this same lesson. A species may begin by imagining the sky as nearby. Then it learns that planets are distant. Then stars. Then galaxies. Eventually, it realizes the universe is too large to physically possess. The final step of maturity may be accepting that knowledge does not require ownership. We can understand something without reaching it. We can value something without touching it. We can be transformed by a galaxy whose light began traveling before our species existed. This does not mean exploration is pointless. It means exploration has limits and forms. Within the solar system, machines and perhaps humans can travel. Within the galaxy, future probes may one day cross to nearby stars. Across the local group, maybe only very advanced machines or civilizations thinking across immense time could attempt a journey. Beyond that, the expansion of the universe may make physical travel meaningless or impossible. But observation remains. Mathematics remains. The light that reaches us remains. Gravity's fingerprints remain. The universe offers many ways to know it, but not all ways to enter it. This is humbling. A galaxy is not small because we can photograph it. A void is not crossed because we can map it. A cluster is not near because we can name it. The act of seeing can make the universe feel close, but understanding restores the distance. When you look at an image of hundreds of galaxies, remember what is hidden between them. Not just black pixels. Not just empty background. Millions of light years, gas too thin to see, dark matter shaping invisible paths, ancient photons traveling alone, voids widening with time, signals that may never arrive, worlds that may never know one another exist. The darkness is not empty decoration. It is the dominant scale. The galaxies are the punctuation marks. The spaces between them are the sentence. And that sentence is written across time. The Milky Way itself is part of that sentence. Our galaxy feels enormous from inside. It contains the sun, every planet we know directly, every human life, every spacecraft ever launched, and every night sky we have ever seen. But from outside, it is one spiral among many, and from farther away, it becomes one faint point in a cosmic web. Our entire history belongs to one island of light. This should not make Earth feel worthless. It should make it feel rare in a different way. A tiny world inside one galaxy has developed beings capable of measuring distances between galaxies. A short-lived species has learned that its nearest major neighbor is millions of light years away. Matter inside the universe has become aware of the universe's scale. That awareness may not change the distance, but it changes what the distance means. The abyss is no longer only empty. It is understood. Not fully, never fully, but enough to know that the visible universe is far larger than human intuition ever expected. Enough to know that galaxies are not arranged for our convenience. Enough to know that travel, communication, and knowledge are three different things. Enough to know that some parts of reality can be seen, but never reached. As this journey ends, imagine standing under a dark sky far from city lights. The Milky Way stretches overhead. Andromeda appears as a faint patch if your eyes are patient enough. It looks small, almost fragile, a soft blur in the darkness. But that blur is an entire galaxy. Its light has traveled more than 2 million years. Between you and it lies a darkness so wide that even the fastest possible message becomes ancient before arrival. Beyond Andromeda lie groups, clusters, filaments, and voids. Beyond those, galaxies whose light began traveling when Earth was young. Beyond those, the early universe, and beyond our horizon, perhaps more space that no signal has yet revealed. The sky is not close. It is not flat. It is not a ceiling. It is depth beyond depth, history behind history, distance behind distance. Every faint galaxy is a reminder that reality is larger than experience. Every dark gap is a reminder that the universe is mostly separation. Every ancient photon is proof that the abyss can still speak. The distance between galaxies is worse than we imagine, because imagination usually compresses what it cannot feel. It turns millions of light years into a line on a screen. It turns clusters into dots. It turns cosmic voids into dark spaces between bright things. But the truth is greater and colder and more beautiful. The galaxies are not close. They are not waiting just beyond the Milky Way like neighboring cities. They are separated by distances that challenge communication, travel, identity, and time itself. And yet, across those distances, light keeps arriving. A silent stream of evidence from islands we may never touch. Perhaps that is the final gift of the universe. It may not allow us to cross every ocean, but it allows us to see the lights on the far shore. It allows us to know that something is there. It allows one small planet circling one ordinary star inside one ordinary galaxy to look into the darkness and understand that the darkness is filled with unreachable worlds. So when you see a galaxy in an image, do not think only of its shape. Think of the journey its light survived. Think of the millions or billions of years hidden inside that glow. Think of the voids between here and there. Think of the civilizations that could rise and vanish before a message arrives. Think of the future in which many of those galaxies fade forever beyond view. And then remember that you are seeing them now. During this brief cosmic window, from this tiny world, at this exact moment in the history of the universe, the distance between galaxies may be worse than anything we can imagine. But the fact that we can understand even a part of it is one of the most astonishing things humanity has ever done. The universe is vast beyond reach. The galaxies are separated by oceans of time. And still, tonight, their ancient light arrives quietly, patiently, across the darkness, just to tell us that we are not the only island in the cosmic sea.